right, so we have a couple of limits. I will tell you right away that the top needs to be handled differently than the bottom limit. So we're going to do the top, and then we're going to insert a new shortcut here. So it's limits with definition derivative, and it's power rule. Okay, it's going to be both on both of these. So we look up top, we try direct substitution, we put it in 0. Can't divide by 0, so you don't do that. You look at it and you think, hey, can I factor this? There's no way you can factor. All right? So you are stuck multiplying by the conjugate. And we never expand. We never, ever expand the denominator. Ever. Ever. Did I say ever? Yeah, I said ever. Ever. So there it is. In the numerator, guys, I love conjugates because we don't have to think very much. I get 4 plus x minus 4. Oh, look what happened. The 4's cancel. Oh, so nice. And x over x is 1. So I'll cancel this x. And now if I insert 0, the bottom is no longer 0. Square root of 4, I put in 0 here. Square root of 4 is 2. 2 plus 2 is 4. So the answer is 1 4. All right, everybody. That is all correct. Awesome. I am going to now do this same problem a different way. So if I get rid of some of the pencil marks up here, would everybody agree that the hardest part of this problem for students is always this? I don't see 2 here. I see square root of 4. And then I start thinking, oh, this is the limit as x approaches 0 of f of x plus a minus f of x, a, all over h. And I look right away, and I can now see, if I write square root of 4 instead of 2 there, that a is 4, right? And I actually can see the function. I think the function f of x is
4 plus x.
How about square root of x? And if you look now after I write it, you should be able to see x plus 4 or 4 plus x is the square root of that, right? And if I just put 4 in for a, it's just square root of 4, which was a whole number 2. All right. Bear with me. I know this is tough. I'm not. These are hard problems as we introduce them. Let's get rid of the circles. All right. There. All right. So if I move this down now. I think this is still a4. Guys, do you guys agree this is f of x equals x to the 1/2 power? All right. What's the derivative of x squared? 2x. What's the derivative of x cubed? 3x squared. So say it, Chelsea. 1/2 x to the, now here's the hard part. X what? Negative 1/2. Right on. Take away 1. 1/2 minus 1 is negative half. Well, hang on, Billy Ray. Let's try putting in, what was the a value? 4. Let's try. All right, we'll do it in a different color. It's so important. All right, 1/2 times 4 to the negative half. Well, we know that negative half has to be, it's 1 over 4 to the half. So it's half. What's half times half? Whoop! Whoa. So when we have now, instead of just negative exponents or power or positive exponents, as long as it is x to a power, we can use the power rule. It can even be fractional exponents. And everybody.
If it was, say, like minus 3, we use square root of 9 because 9 and square root of 4 are the same.
Exactly. So you put 9 here, and you had 3 here. That would just make.
I mean, because if they're not squares of each other.
Oh yeah. You can listen. If the numbers don't match, you were asking if it's 9 here and this is still 2.
Yeah,
you're done. It's a horrible problem. Yeah, it's something else. It's just.
Can you still do the conjugate?
You can try, and it's
but
gonna.
They won't cancel.
They won't cancel, and then what do you know if it doesn't cancel if you try? Does not exist. up in the world of I've proven that this one really stinks. Everybody, you do not want to multiply out 1 plus h to the 12th. So we're going to look at this limit, and we're not going to do it longhand by definition derivative. Up here we did it longhand, definition derivative, and then we did the shortcut. The only way to do something to the 12th power is to do the shortcut. You guys, what do you think I want to do to the 1? Well, I want to think of.
You want to think of it as 1 to the 3rd.
I want to think of how many. I want to think of this as 1 to the 12th power.
Oh, because it's the same.
So I have the same power. You see what I mean? I got to the same function. And now what's a? A is going to be 1. What's the function f of x? X to the 12th. Everybody, we're getting good at this now. No different color. What's f prime of x? 12x to the 11. What value of a do we want to check at? 1. Now, again, be careful. What's the value of when you put 1 in here? What do you get? 1 times 12, so it's 12. The answer is 12. And you notice I did not take 1 plus h to the 12th. All right? We did the proof of showing that the first 2 terms are all that mattered of Pascal's triangle on this one. So the proof we did on this, if I erase this, so I will leave this, so let's go 100%, let's leave it. The proof we did, kind of to show and make us think about it, was this. I could write limit as h approaches 0 of 1 to the 12th plus, and the first one over is 12, 1 to the 11th times h plus, and every other term hereafter has h squared, right? The next term in Pascal triangle is h squared. The next term is h cubed, all the way to, so the next term had h squared in it, all the way to h to the 11th, minus 1, all over h. And what happens here is what?
Oh, it's h to the 12th.
12, I'm sorry, 12, thank you, h to the 12th. Yeah, so what happens, the negative 1 and the positive 1 cancel. You're left with 12, 1 to the 11th h, and all this stuff is h. So, and this becomes, all these h's cancel, but all these h's go away, and you're left with 12, 1 to the 11th, which matches our derivative with 1 in it. It is. But at that same time, what we much prefer is the ability to look at the derivative. We see this as a derivative, f prime, and find the function in the a value. This takes practice, and we will work on it in class. Internet, you got to practice this. You'll never see it if you don't practice. Keep practicing.